Select problems with the solutions, statistics and probability. Question number 1. The mean of n observations is x bar. If the first term is increased by 1, the second term is increased by 2, and so on, what will be the new mean? Given x1 plus x2 plus x3 plus dot 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 plus xn whole divided by n equal to x bar. Equation 1. New mean is x1 plus 1 plus x2 plus 2 plus x3 plus 3 plus dot 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 plus xn plus n whole divided by n. That's equal to collecting the first terms together and collecting the second terms together, we get x1 plus x2 plus x3 plus dot 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 plus xn plus 1 plus 2 plus 3 plus dot 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 plus n whole divided by n. That's equal to x1 plus x2 plus x3 plus dot 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 plus xn whole divided by n plus 1 plus 2 plus 3 plus dot 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 plus n whole divided by n. The first term is x bar. x1 plus x2 plus x3 dot 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 plus xn whole divided by n is nothing but x bar plus 1 plus 2 plus 3 dot 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 plus n is sum of first n natural numbers, that is equal to n into n plus 1 by 2 whole divided by n, that is x bar plus n plus 1 by 2. Hence the mean is increased by n plus 1 by 2. That's all. Question number 2. If the sum and mean of a data are 407 and 11 respectively, then the number of observations in the data is x bar equal to sigma xi by m. X bar is given as 11. Sigma xi is given as 407. We have to find the value of n. So 11 equal to 407 divided by n. That is n equal to 407 divided by 11. That is 37. Number of observations is 37. That's all. Question number 3. If we multiply each value of a data by k, then standard deviation gets multiplied by k. Question number 4. If we multiply each value of a data by k, then the variance gets multiplied by k square. Question number 5. The standard deviation of a data is 2.8. If phi is added to all the values of the data, it is all the data values, then the new standard deviation is the same, 2.8. Question number 6. If S is the standard deviation of the values P, Q, R, then standard deviation of 3P, 3Q, 3R is 3S, and the standard deviation of P minus 3, Q minus 3, R minus 3 is S. Question number 7. The coefficient of variation depends upon standard deviation and mean of the data. The mean, question number 8, the mean and standard deviation of a data are 8 and 2 respectively. The coefficient of variation of the data is, coefficient of variation is sigma by x bar into 100%. That is 2 by 8 into 100%. that is 1 by 4 into 100%. That's equal to 25%. So the mean and standard deviation of a data are 8 and 2 respectively. The question of variation of the data is 25%. Question number 9. When comparing two data, the data with greater coefficient of variation is more inconsistent. Greater coefficient of variation is more inconsistent. Or we can say, when comparing two data, the data with lesser coefficient of variation is less inconsistent. Question number 10. Show that the sum of the deviations of a data from its mean is 0. Sigma xi minus x bar, consider. That's equal to sigma I equal to 1 to n xi minus x bar. That's equal to I varies from 1 to n. Therefore x1 minus x bar plus x2 minus x bar plus x3 minus x bar plus dot dot dot. Finally xn minus x bar. That's equal to collecting the first terms of each bracket, x1 plus x2 plus x3 plus dot 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 plus xn minus collecting the second terms from each bracket, x bar plus x bar plus x bar plus x bar n times, that is n x bar. That's equal to x1 plus x2 plus x3 plus dot 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 plus xn minus n into what is x bar, x1 plus x2 plus x3 plus dot 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 plus xn whole divided by n. N will get cancelled, so we get x1 plus x2 plus x3 plus dot 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 plus xn minus bracket x1 plus x2 plus x3 plus dot 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 plus xn. Both the brackets get cancelled, get 0. So the sum of the deviations of a data from its mean is always 0. That's all. Question number 11. If A and B are mutually exclusive events, prove that probability of A union B equal to probability of A plus probability of B. So we have the sample space S, two events A and B. The events are mutually exclusive. So A intersection B must be phi. That is A and B must be disjoint sets. Let number of elements in the sample space be n. Number of elements in A, P. Number of elements in B, Q. Now probability of A union B, that is what we want to find. Probability of A union B equal to number of elements in A union B divided by number of elements in S. Since A and B are disjoint sets, the number of elements in A union B equal to number of elements in A plus number of elements in B, that is P plus Q. So P plus Q divided by n. Divide term by term, that is P by n plus Q by n. That is number of elements in A divided by number of elements in S plus number of elements in B divided by number of elements in S. That is probability of A plus probability of B. So we have proved when A and B are mutually exclusive events, probability of A union B equal to probability of A plus probability of B. The sum is done. Question number 12. Prove probability of A bar, that is probability not A, is equal to 1 minus probability of A. We have the sample space S. Capital A is some event in the sample space. We have A bar, the complement of A. We have A union A bar equal to S. A union A bar equal to S. Therefore, probability of A union A bar equal to probability of S. A and A bar are mutually exclusive events because A and A bar are disjoint. Therefore, probability of A union A bar equal to probability of A plus probability of A bar equal to probability of S. S is sure event, so probability of S is 1. And therefore, probability of A bar equal to 1 minus probability of A. That's all. Question number 13. State and prove addition theorem on probability. The statement of addition theorem on probability is, if A and B are any two events, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now we have the diagram. A and B are any two events, and we have A intersection B bar, A bar intersection B, and we have A intersection B. From the figure, we have A union B. A union B is equal to A union A bar intersection B. A union B equal to A union A bar intersection B. Therefore, probability of A union B equal to probability of A union A bar intersection B. Now, A and A bar intersection B, A and A bar intersection B are mutually exclusive events. That is, A intersection A bar intersection B is empty set. Therefore, probability of A union A bar intersection B is equal to probability of A plus probability of A bar intersection B. Let us call this as equation 1. Now we find the value of probability of A bar intersection B. From the diagram, we have A bar intersection B union A intersection B is equal to B. A or intersection B union A intersection B is equal to B. Therefore, probability of A bar intersection B union A intersection B equal to probability of B. The events A bar intersection B and A intersection B are mutually exclusive events because their intersection is empty. That is, A bar intersection B intersection A intersection B is empty set. Therefore, probability of A bar intersection B plus probability of A intersection B equal to probability of B. From this we can write down the value of probability of A bar intersection B. Probability of A bar intersection B equal to probability of B minus probability of A intersection B. This is equation 2. We can use equation 2 in equation 1. In equation 1, probability of A bar intersection B, that can be replaced by probability of B minus probability of A intersection B. So using 2 in 1, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. That is exactly the addition theorem on probability. Question number 14. Write down an expression for probability of A union B union C. Probability of A union B union C equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. This is the expression for probability of A union B union C. This is actually addition theorem on probability for 3 events. Question number 15. How many terms will there be in the expansion of probability of A union A1 union A2 union A3 union AN? Probability of A union B. In the expansion by addition theorem on probability, there will be 3 terms, that is 2 square minus 1 terms. Probability of A union B union C in the expression for probability of A union B union C by addition theorem on probability for 3 events, there are 7 terms, that is 2 cubed minus 1 terms. By analogy, in probability of A1 union A2 union A3 union AN, there will be 2 to the power of n minus 1 terms. Question number 16. When A and B are mutually exclusive events, probability of A intersection B is 0, because probability of A intersection B equal to probability of phi. A and B being mutually exclusive events, their intersection is empty. So probability of A intersection B equal to probability of phi. Probability of phi is probability of the impossible event, which is 0. Question number 17. Is probability of A union B equal to probability of A plus probability of B always true? No. Probability of A union B equal to probability of A plus probability of B only when A and B are mutually exclusive events. Question number 18. Is probability of A union B equal to probability of A union B plus probability of A intersection B equal to probability of A plus probability of B true? Yes. By addition theorem on probability, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. When we take probability of A intersection B to the left hand side, probability of A union B plus probability of A intersection B equal to probability of A plus probability of B. That's all. Question number 19. Prove that probability of A intersection B bar is equal to probability of A minus probability of A intersection B. We have A intersection B bar union A intersection B equal to A. Therefore, probability of A intersection B bar union A intersection B equal to probability of A. A intersection B bar and A intersection B are mutually exclusive events. That is, their intersection is empty. Therefore, the left hand side is probability of A intersection B bar plus probability of A intersection B, and that's equal to probability of A. Therefore, probability of A intersection B bar equal to probability of A minus probability of A intersection B. That's all. Question number 20. Prove that probability of A bar intersection B equal to probability of B minus probability of A intersection B. We have A bar intersection B union A intersection B equal to B. Therefore, probability of A bar intersection B union A intersection B equal to probability of B. On the left hand side, A bar intersection B and A intersection B are mutually exclusive events because their intersection is empty. Therefore, the left hand side becomes probability of A bar intersection B plus probability of A intersection B equal to probability of B. That is, probability of A bar intersection B is equal to probability of B minus probability of A intersection B. That's all. Question number 21. Prove probability of A bar union B bar plus probability of A intersection B equal to 1. Left hand side. Probability of A bar union B bar plus probability of A intersection B equal to, by De Morgan's law, probability of A bar union B bar equal to probability of A intersection B whole bar. That is, union of complements is equal to complement of the intersection plus probability of A intersection B. Then probability of X bar equal to 1 minus probability of X. So probability of X bar equal to 1 minus probability of X. Probability of A intersection B whole bar equal to 1 minus probability of A intersection B plus probability of A intersection B. The last two terms get cancelled, giving us the answer 1. That's all. Question number 22. If probability of A intersection B equal to 0.3, probability of A bar intersection B equal to 0.45, then find probability of B bar. We have A bar intersection B union A intersection B equal to B. That is, probability of A bar intersection B union A intersection B equal to probability of B. A bar intersection B and A intersection B are mutually exclusive events. Therefore, the left hand side becomes probability of A bar intersection B plus probability of A intersection B, and that's equal to probability of B. That is, 0.45 plus 0.3 is equal to probability of B. That is, 0.75 is equal to probability of B. Hence, probability of B bar equal to 1 minus probability of B, that's equal to 1 minus 0.75, that's equal to 0.25. The problem is done. Question number 23. E and F are two events such that probability of E equal to 1 by 4, probability of F equal to 1 by 2, and probability of E intersection F equal to 1 by 8. Find probability of E bar intersection F bar. Probability of E bar intersection F bar equal to probability of E union F whole bar by De Morgan's law. By De Morgan's law, intersection of complements is equal to complement of the union. Intersection of complements is equal to complement of the union. Probability of E bar intersection F bar equal to probability of E union F whole bar. We have probability of X bar equal to 1 minus probability of X. Probability of A bar equal to 1 minus probability of A. Therefore, probability of E union F whole bar equal to 1 minus probability of E union F. That's equal to 1 minus bracket addition theorem on probability for two events. That is, probability of E plus probability of F minus probability of E intersection F. That is 1 minus bracket probability of E 1 by 4 plus probability of F 1 by 2 minus probability of E intersection F 1 by 8. That is 1 minus LCM 8, 2 plus 4 minus 1. That's equal to 1 minus 5 by 8. That is LCM 8. 8 minus 5 by 8. That's equal to 3 by 8. Question number 24. A die is rolled. Let E be the event. Die shows number 4. And F be the event. Die shows an even number. Are E and F mutually exclusive events? The sample space for the experiment of rolling a die once is S equal to 1, 2, 3, 4, 5, 6. E is the event of getting 4 on the die, and F is the event that the die shows an even number, F equal to 2, 4, 6. E intersection F is the singleton set 4, which is not empty set. E intersection F is not empty set. That is, E and F are not disjoint. Therefore, E and F are not mutually exclusive events. Question number 25. Tickets numbered 1 to 20 are mixed up and then a ticket is drawn. What is the probability that the ticket drawn has a number which is a multiple of 3 or 5? So the sample space is 1, 2, 3, dot, 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 up to 20. Number of elements in the sample space is 20. The event A is getting a number which is a multiple of 3 or 5. So the A event may be described as 3, 6, 9, 12, 15, 5, 10, 20. Number of elements in A is 9. Probability of A equal to number of elements in A, that is 9, divided by number of elements in S, that is 20. So the probability of the required event is 9 by 20. That's all. Question number 26. 2 dice are tossed once. What is the probability that the total score is a prime number? When 2 dice are tossed once, the sample space for that random experiment will consist of 36 elements. The event is getting a total score which is a prime number. So the event A is 1, 1, 1, 2, 1, 4, 1, 6, 2, 1, 2, 3, 2, 7, 3, 2, 3, 4, 4, 1, 4, 3, 5, 2, 5, 6, 6, 1 and 6, 5. Because in each case the total is a prime number. 1 plus 1, 2, prime number. 1 plus 2, 3, prime number. 1 plus 4, 5, prime number. 1 plus 6, 7, prime number. 2 plus 1, 3, prime number. 3 plus 4, 7, prime number. 6 plus 5, 11, prime number. So A is the event A of getting a total score which is a prime number is described by the event A. Now number of elements in A is 15. So probability of A is number of elements in A, that is 15, divided by number of elements in the sample space, that is 36. That's equal to 5 by 12. Question number 27. What is the probability that a leap year selected at random will contain 53 Mondays? Leap year consists of 366 days. Divide 366 by 7, getting quotient 52 and remainder 2. So leap year having 366 days consists of 52 completed weeks plus 2 extra days. The 2 days may be, that is a sample space, Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Now the year should have 53 Mondays. So the favorable cases are Sunday, Monday and Monday, Tuesday. Number of elements in the sample space is 7. Number of elements in A is 2. So probability that the year contains 53 Mondays, that is probability of A is number of elements in A 2 divided by number of elements in S 7. So the required probability is 2 by 7. Instead of Mondays, we can consider any other day, Tuesday, Thursday. The probability will be the same. That is the probability that a leap year selected at random will contain 53 Saturdays. The answer will be the same, 2 by 7. That's all. Question number 28. What is the probability that a non-leap year selected at random contains 53 Saturdays? Non-leap year consists of 365 days. Divide 365 by 7, getting quotient 52 and remainder 1. So a non-leap year will consist of 52 completed weeks and 1 extra day. The one day may be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday or Saturday. Now we want the probability that a non-leap year selected at random contains 53 Saturdays. So the event A is the singleton set Saturday. Number of elements in A is 1. Number of elements in sample space is 7. So probability that a non-leap year selected at random will contain 53 Saturdays is number of elements in A 1, number of elements in sample space 7. So 1 by 7. That's all. Question number 29. Find the probability of selecting a black card or a 6 from a deck of 52 cards. Probability of selecting a black card or a 6 is equal to total number of cases 52 in the denominator. Total number of black cards is 26. Clover cards and spade cards. And number of cards which bear a number 6 is 4. Of those 4 cards, 2 cards have already been included in the 26 black cards. So the other 2 cards are now to be taken. So the number of cards which are either black or bear a number 6 is 26 plus 2. Therefore the required probability is 26 plus 2 divided by 52. That is 28 by 52. That is 7 by 30. Let me repeat. We have to find the probability of selecting a black card or a 6. Black card or a card bearing number 6. Total number of black cards is 26. That 26 cards include 2 black cards. So the other 2 cards are there. That is diamond 6 and heart 6. So total number of cards which are black or bear a number 6 is 28. So 28 by 52 is the required probability. That is 7 by 30. A little alternative method of doing the problem. Probability of B, that is probability of taking a black card, is 26 by 52. Total number of cards 52. Total number of black cards 26. Number of spade cards 13. Number of clover cards 13. So total number of black cards 26. Probability of drawing a card bearing a number 6 is 4 by 52, because there are 4 cards which bear a number 6. And probability of B intersection 6, that is probability of drawing a card which is black as well as 6, is 2 by 52, because there are 2 cards which are black as well as bear a number 6, that is a clover 6 and a spade 6. Now probability of B union 6, that is drawing a black card or a card which bears a number 6, equal to, by addition theorem on probability of B plus probability of 6 minus probability of B intersection 6, that's equal to 26 by 52 plus 4 by 52 minus 2 by 52. LCM 52, 26 plus 4 minus 2, that is 28 by 52, that's again 7 by 13. You get the same answer. Question number 30. What is the probability that 2 friends will have first subdivision same birthday, second subdivision different birthdays in a year of 365 days? Let X and Y be 2 friends. The birthday of X may fall on any one of those 365 days. Similarly, the birthday of Y may fall on any one of 365 days. Therefore, the total number of ways in which their birthdays may happen in a year of 365 days is 365 into 365. That is, total number of cases is 365 into 365. That is, number of elements in the sample space is 365 into 365. Now consider the first subdivision. We want to find the probability that the 2 friends will have the same birthday. Then the birthday of X may fall on any one of 365 days. Then the birthday of Y must also fall on the same day. Therefore, the total number of favorable cases is only 365, so that they have the same birthday. Therefore, probability of A is 365 divided by 365 into 365. That's equal to 1 by 365. Then second subdivision. Number of elements in the sample space is again 365 into 365. Now they must have different birthdays. So the birthday of X may fall on any one of the 365 days, and the birthday of Y may fall on any one of those 364 days, excluding the day on which the birthday of X occurs. Let me repeat. The birthday of X may occur on any one of those 365 days, but the birthday of Y must occur on any one of those 364 days, excluding the day on which the birthday of X falls. Therefore, the number of favorable cases is 364 into 365. 365 into 364. So probability of A, probability that the 2 have different birthdays, is 365 into 364 whole divided by 365 into 365. That is 364 divided by 365. That's all. Question number 31. 3 letters are put in 3 addressed envelopes at random. Find the probability that number 1, none of the letters are put in right envelopes. Number 2, all are put in right envelopes. Number 3, at least one is put in right envelope. Different ways of putting the letters 1, 2, 3 in 3 envelopes. Is the sample space? Yes. So S is 1, 2, 3, 1, 3, 2. Then 2, 1, 3, 2, 3, 1. Then 3, 1, 2, 3, 2, 1. So the sample space consists of 6 elements. Subdivision 1. None of the letters are put in right envelopes. So the event A is 2, 3, 1, 3, 1, 2. None of the letters are put in right envelope. 2 is not put in right envelope. 3 is not put in right envelope. 1 is not put in right envelope. Similarly, 3 is not put in right envelope. 1 is not put in right envelope. 2 is not put in right envelope. Right envelope is 1, 2, 3. 1, 2, 3 is the correct position. 1 goes to the right envelope. 1. 2 goes to the right envelope. 3 goes to the right envelope. So, number of elements in A is 2. Probability of A is 2 by 6. That is 1 by 3. Then subdivision 2. All are put in right envelopes. That is the event B is 1, 2, 3. All are put in right envelope. 1 goes to the right envelope. The letter 2 goes to right envelope. 3 goes to right envelope. Number of elements in B is 1. So the required probability is 1 by 6. Then third subdivision. At least one is put in right envelope. The event C is 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 2, 1. At least one letter is put in right envelope. Number of elements in C is 4. So the probability of C is 4 by 6. That is 2 by 3. That's all. Question number 32. A pair of dice is rolled once. Find the probability that the sum of the face numbers obtained is number 1, neither prime nor odd. Number 2, divisible by 7. Number 3, divisible by 5. The sample space for the random experiment of rolling a pair of dice once is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 and so on. The sample space will have 36 elements. 1, 1 total 2, 1, 2 total 3, 1, 3 total 4. So we are writing totals of the numbers obtained on top of each case. First subdivision, neither prime nor odd. The sum obtained, the sum of the face numbers must be neither prime nor odd. Then that even E1 is described by 1, 3, 1, 5, 2, 2, 2, 4, 2, 6, 3, 1, 3, 3, 3, 5, 4, 2, 4, 4, 4, 6, 5, 1, 5, 3, 5, 5, 6, 2, 6, 4, 6, 6. Where the sum is neither prime or odd. The sum is neither prime nor odd. Number of elements in E1 is 17. So the required probability is 17 by 36. Third subdivision, divisible by 7. So the event is E3, 1, 4, total is divisible by 5. 2, 3, total is divisible by 5. 5, 5, the total is divisible by 5. So E3 consists of 1 4 2 3 3 2 4 1 4 6 5 5 and 6 4. Number of elements in E3 is 7. So the required probability is 7 by 36. That's all. Question number 33. Two dice are rolled once. Find the probability of getting the product of phase numbers. Number 1, neither prime nor odd. Subdivision 2, divisible by 7. Subdivision 3, divisible by 5. So the sample space will consist of 36 elements. The products are denoted at the top of every case. 1 1 product 1, 1 2 2, 1 3 3, 4 into 4 16, 4 into 5 20. So the first case, the event E1, the product of the phase numbers is neither prime nor odd. Then E1 consists of the cases 1 4, 1 6, 2 2, 2 3, 2 4, 2 5, 2 6 and so on. The number of elements in E1 is 24. So the required probability that the product of the phase numbers is neither prime nor odd is 24 by 36, that is 2 by 3. Subdivision 2, the event E2, the product of the phase numbers got is divisible by the number 7. No product of the phase numbers is divisible by 7. Therefore, E2 is empty set. So probability of E2 is 0. Then third subdivision, the product is divisible by 5. So E3 consists of the event of getting product of phase numbers divisible by 5 is 1 5, product is divisible by 5. 2 5, product is 10, divisible by 5. 3 5, product is 15, divisible by 5. 4 5, 5 1 and so on. Number of elements in E3 is 11. So the probability of getting product of phase numbers divisible by 5 is 11 by 36. That's all. Question number 34. A die marked 1 1 1, 2 2 2 and another die marked 1 1, 2 2, 3 3 are rolled once. Find the probability of getting the sum of the phase numbers as 5. So the numbers on the first die, only two numbers, 1 and 2. The numbers on the second die, 3, 1 2 3. Therefore the total number of outcomes of the random experiment of rolling the two die is 2 into 3, that is 6. That is, number of elements of the sample space is 6. The elements are 1 1, 1 2, 1 3, 2 1, 2 2 and 2 3. Probability of getting sum of the phase numbers 5. The event E is 2 3. 2 3 is the only case where the sum of the phase numbers is 5. Number of elements in E is 1. Number of elements in the sample space is 6. So the probability that the sum of the phase numbers is 5 is number of elements in E is 1, number of elements in sample space is 6. So probability of E is 1 by 6. Question number 35. Calculate the variance of the following data. Class intervals are given: 4 to 8, 8 to 12, 12 to 16, 16 to 20. Frequencies. The corresponding frequencies: 3, 6, 4 and 7. Class intervals: 4 to 8, 8 to 12, 12 to 16, 16 to 20. the mid-x, the mid values of class intervals xi. 4 plus 8 divided by 2, 6. 8 plus 12 divided by 2, 10. 12 plus 16 divided by 2, 14. 16 plus 20 divided by 2, 18. So the values of xi 6, 10, 14, 18. The common difference of xi is 4. So we can do by step deviation method with the step 4. Now we can take 10 as the assumed mean. So di equal to xi minus 10 divided by 4. Step C is 4. Now the frequencies are given 3, 6, 4, 7. Total of the frequency 20. N equal to sigma fi, that's equal to 20. Now variance is sigma squared equal to c squared into sigma fi di squared divided by n minus sigma fi di by n whole square. If it is standard deviation, we would have written the formula sigma equal to c into square root of sigma fi di squared by n minus sigma fi di by n whole square. Here we are doing sigma squared, so we get c squared into sigma fi di squared divided by n minus sigma fi di by n whole square. So fi columns 3, 6, 4, 7, total 20, n equal to 20. Then di column 6 minus 10 divided by 4 minus 1. 10 minus 10 divided by 4 0. 14 minus 10 divided by 4 1. 18 minus 10 divided by 4 2. Then fi di 3 into minus 1 minus 3. 6 into 0 0. 4 into 1 4. 7 into 2 14. Sigma fi di is 15. Then di squared minus 1 whole squared 1, 0 squared 0, 1 squared 1, 2 squared 4. Fi di squared, fi into di squared, 3 into 1 3, 6 into 0 0, 4 into 1 4, 7 into 4 28. Sigma fi di squared is 35. Substitute in the formula. Sigma squared equal to 16 into c is 4, so c squared 16. 16 into 35 by 20 minus 15 by 20 whole square, that is 16 into 1.75 minus 0.75 whole square, that is 16 into 1.75 minus 0.5625, that's equal to 16 into 1.1875, that is approximately equal to 90. That's all. Question number 36. Calculate the coefficient of variation for the following data. Class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. The corresponding frequencies 11, 29, 18, 4, 5 and 3. Class interval 0 to 10, 10 to 20, 20 to 30 and so on. The mid-x, that is midpoint of class intervals. 0 plus 10 by 2 5, 10 plus 20 by 2 50, 20 plus 30 divided by 2 25 and so on. So the xi values are 5, 15, 25, 35, 45 and 55. The xi values increase by 10. So we can do by step deviation method with the step c equal to 10. Now we can take 25 as the assumed mean. So di equal to xi minus 25 by 10. Assumed mean is 25. H or c is 10. N is total number of frequencies. Frequencies are given 11, 29, 18, 4, 5, 3. Total is 70. So n equal to 70. Now x bar equal to assumed mean A plus sigma fi di by n into h. H is the same as C. Now di xi minus 25 by 10. So 5 minus 25 divided by 10, that is minus 2. 15 minus 25 divided by 10, minus 1. 25 minus 25 divided by 10, 0. 35 minus 25 divided by 10, 1. 45 minus 25 divided by 10, 2. 55 minus 25 divided by 10, 3. Then di square, minus 2 whole squared 4, minus 1 whole squared 1, 0 squared 0, 1 squared 1, 2 squared 4, 3 squared 9. fi di column. Fi is there, di is there, fi di. 11 into minus 2, minus 22. 29 into minus 1, minus 29. 18 into 0, 0. 4 into 1, 4. 5 into 2, 10. 3 into 3, 9. Sigma fi di is minus 28. Then fi di squared. Fi column, di squared column, multiply. 11 into 4, 44. 29 into 1, 29. 18 into 0, 0. 4 into 1, 4. 5 into 4, 20. 3 into 9, 27. Sigma fi di squared is 124. So substitute in the formula. X bar equal to, assumed mean A is 25 plus sigma fi di. Sigma fi di is minus 28 divided by n is 70 into 10. That is 25 minus 4, that is 21. Then sigma equal to C into square root of sigma fi di squared by n minus sigma fi di by n whole square. That's equal to 10 into square root of 124 by 70 minus 28 by 70 whole square. That is 10 into square root of 1.77 minus 0.4 whole square. That is 10 into square root of 1.77 minus 0.16. That is 10 into square root of 1.61. That is 10 into 1.269. That is 12.69. So we have calculated mean 21. Standard deviation 12.69. We have to calculate coefficient of variation. Formula sigma by x bar into 100%. Sigma 12.69. X bar 21 into 100%. That is 60.43%. The problem is question number 37. Find the mean and variance of the first n natural numbers. Mean x bar equal to sigma xi by n. That is 1 plus 2 plus 3 plus dot 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 plus n whole divided by n. Numerator, sum of the first n natural numbers. So n into n plus 1 by 2 whole divided by n. N will get cancelled. So n plus 1 divided by 2. That is the mean of the first n natural numbers. Then variance, sigma xi squared by n minus sigma xi by n whole square. That's equal to sigma xi squared is 1 square plus 2 square plus 3 square plus dot 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 plus n squared whole divided by n minus sigma xi 1 plus 2 plus 3 plus dot 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 plus n whole divided by n whole square. That is sum of the squares of the first n natural numbers, n into n plus 1, 2n plus 1 by 6 whole divided by n minus sum of the first n natural numbers, n into n plus 1 by 2 whole divided by n the whole square. N will get cancelled. So n plus 1 into 2n plus 1 divided by 6 minus n get cancelled. n plus 1 whole square divided by 4. LCM 12. 2 into n plus 1 into 2n plus 1 minus 3 into n plus 1 whole square. We can take n plus 1 as common factor. So n plus 1 into 2 into 2n plus 1 minus 3 into n plus 1 divided by 12. That is n plus 1 into 4n plus 2 minus 3n minus 3 whole divided by 12. That is n plus 1 into n minus 1 whole divided by 12. That's equal to n squared minus 1 whole divided by 12. So the variance of the first n natural numbers is n squared minus 1 divided by 12. Then the standard deviation would be square root of n squared minus 1 divided by 12. That's all. Question number 38. Find the standard deviation of first 8 natural numbers. The mean of first n natural numbers will be a whole number if n is an odd number. Here n equal to 8 is not 12, it is 8. N equal to 8 is not an odd number. Therefore the mean will not be a whole number. So we do the problem using assumed mean. Sigma equal to square root of sigma di squared by n minus sigma di by n whole squared. Xi values 1, 2, 3, 4, 5, 6, 7, 8. Now let us take phi as the assumed mean. That is capital A is phi. Di equal to xi minus a, that is xi minus phi. Number of items in the data 8, n equal to 8. Now di xi minus 5, 1 minus 5 minus 4, 2 minus 5 minus 3, 3 minus 5 minus 2, 4 minus 5 minus 1, 5 minus 5 0, 6 minus 5 1, 7 minus 5 2, 8 minus 5 3. Total minus 4. Sigma di minus 4. Di square minus 4 whole square 16, minus 3 whole square 9, minus 2 whole square 4, minus 1 whole square 1, 0 square 0, 1 square 1, 2 square 4, 3 square 9. Sigma di square 44. So sigma equal to square root of sigma di square by n, that is 44 by 8 minus sigma di by n whole square, that is minus 4 by 8 whole square. That's equal to 11 by 2 minus 1 by 2 whole square, that is 5.5 minus 1 by 4, that is square root of 5.5 minus 0.25. That's equal to square root of 5.25, that gives 2.3. Alternative method of doing the problem. We have the formula derived, sigma equal to square root of n squared minus 1 whole divided by 12. Here n equal to 8. This formula sigma equal to square root of n squared minus 1 divided by 12 gives the standard deviation of first n natural numbers. Here n equal to 8. So square root of n squared, that is 8 square minus 1 by 12. That's equal to square root of 64 minus 1 by 12. That's equal to root of 63 by 12. That is square root of 5.25. That is 2.3. We get the same answer. That's all.